Hi friends, we are going to solve another problem from CSES graph algorithm, that is building room. Let's open this. So in this problem we are given n cities with starting with the one index, and we are given m roads between them. And these are two directional road such that we can go from one like left to right and left to right both sides. So now some of these cities are connected with M roads, and we need to figure out how many more roads we need to construct so that all of these cities are connected with each other by any of the routes. So in the given case, we have four cities and two roads only. So the first road starts from one and ends to two, or vice versa, and the second road is between three and four. So we can see one is connected to two, but one is not connected to either three or four by any means, and three is connected to four, but not one and two. So the solution over here would be, if we are able to connect the road two and three, the seat two and three, we would be able to communicate between one and four also by going from one to two, then two to three, and three to four. So in this way, we need to find the minimum number of roads, and we also need to find the cities between which this road should be constructed. And there can be many possible solutions. Like in this case, we can either connect two and three, or one and three, or one and four, or two and four. Any of this is a valid solution. So we can print any one of the valid solution over here. So for approaching this problem, like the n and m are of the order of 10 to the power 5, so this should be order of n only, the solution. And for solving this question, what we can do, we can start doing BFS and DFS from any of the node, and we can start marking the other node as visited here. So if we start our DFS from 1, we can go till 2 only. So this is one BFS, and it will cover all of the cities which can be to which we can travel from city 1. And similar, we will start a DFS from city 3 and not city 2, because it would be marked as visited when we start the BFS from 1. So in this case, we will have multiple number of BFS, and the number of BFS would indicate the number of new roads we need to connect all of these cities. And whenever we are starting BFS, we can store the name of the city from which we are starting it, so that in the end we can connect all of those cities from which our new BFS is getting started. So let's write the code over here. We will have int n comma m as the input. We will create a of vector of int to create our graph. We will call it adjacent. Its size would be n. And m times we are taking the input for the road, and as our cities are one index, we are going to create it as a zero index only, because our adjacent is of size n. So we can do u minus minus and v minus minus. Only we will push it in our adjacency graph. So now our graph is completed. Now we will create a DFS function that will return void. It will take int as a starting index or a starting city, you can say. We'll implement this later. And we will also need a visited array. Initialize it with false. And now we will start our DFS. If it is not visited, we will start a DFS from here. So let's implement this function now. So whenever we go on some node, we will mark it as visited. And now we will go to the adjacency nodes of this. And if it is not visited yet, we will start the DFS. So now we have X number of DFS over here, and our new number of roads would be x minus 1, because for connecting x nodes we need x minus 1 roads. So let's wrap it like this, and let's initialize a new vector. We can say unconnected city, and you can push it here. So our new number of road we can print here. It would be the size of this minus 1. And we can connect the first node with every other node. So we can start with I equal to 1, and we can print the first node and the ith node. But remember, we have converted it to 0 index, so now we have to convert it back to 1 index. Now our code is complete. Let's try to compile it and run. We forgot to add a space over here. Yeah, now it will work. Our output is 1, 3, but in the example it is 2 and 3, but 1 and 3 is also a valid solution. So we will go and submit this. All our test cases have been passed. There are some warnings over here just because we have not converted this long into int. So whenever we are using some size, we can put int over here. But that's not the issue to pass the cases right now. Thank you for watching. See you in the next video.